Imagine drifting through space. You're weightless, floating in the silence of the cosmos. But what if you stayed out there for 10,000 hours? What would happen to your body in this alien environment? In space, your body isn't just on vacation. It's in a constant state of adaptation, battling forces it was never designed to encounter. So, what happens when you spend over a year in microgravity? Let's begin with the basics. Gravity, or the lack of it. Here on Earth, gravity is a constant. It shapes every part of our existence, from the way we walk to the way our blood flows. But in space, gravity loosens its grip. Your body begins to change. One of the first things you'd notice? You'd get taller. Yes, you heard that right. Without gravity compressing your spine, your vertebrae start to expand. You could gain up to 2 inches in height. But don't get too excited. This growth is temporary. The moment you return to Earth, gravity pulls you back down, and you return to your usual height. But growing taller is just the beginning. Your muscles and bones begin to weaken. Why? Because in space, your muscles don't have to work as hard. There's no gravity resisting your movements, so your muscles start to atrophy. That's why astronauts spend about 2 hours each day exercising, just to maintain some muscle mass. But even with that effort, they can lose up to 20% of their muscle strength during a long mission. And then there are your bones. On Earth, your bones are constantly being remodeled to stay strong, a response to the daily stresses and strains of gravity. But in space, without that gravitational pull, your bones lose minerals like calcium. They become weaker, more brittle, just like someone with osteoporosis. But what happens to your body if you're up there for 10,000 hours? You could lose as much as 1% to 2% of your bone mass each month. Over time, this could lead to significant bone density loss, making you more prone to fractures and injuries upon your return to Earth. So what about your heart? In microgravity, your heart doesn't need to work as hard to pump blood throughout your body. Blood, which is usually pulled down by gravity, now pools in your upper body. Your heart starts to shrink, just like your muscles. This might sound like a relief, but it's not. When you return to Earth, your heart struggles to pump blood effectively, leading to dizziness, fainting, and in some cases, more serious cardiovascular issues. The cardiovascular system is highly adaptable, but it's also vulnerable to long-term changes. Spending 10,000 hours in space could result in persistent issues with blood pressure regulation, even after you've returned to Earth. But there's more. The changes aren't just physical, they're also sensory. In space, your sense of taste and smell can diminish. Food might start to taste bland, perhaps due to fluids shifting in your body and affecting your sinuses. It's like having a cold that never goes away. Imagine spending over a year eating food that tastes like cardboard. Astronauts often crave spicy and strong flavors just to get some satisfaction from their meals. However, what's even more concerning is the effect space can have on your vision. Long-term exposure to microgravity can flatten your eyeballs, leading to blurred vision or even permanent impairment. This condition is known as spaceflight-associated neuroocular syndrome, or SANS. Vision changes have been reported by many astronauts, and for some, the effects can last long after returning to Earth. If you spent 10,000 hours in space, these vision problems could become a serious issue, affecting your ability to read, operate equipment, or even navigate your environment. Your body is incredibly adaptable, but it's built for life on Earth. In space, everything changes. Let's talk about radiation. Here on Earth, we're shielded from most of the sun's harmful radiation by our atmosphere and the magnetic field. But in space, you're exposed to much higher levels. Over 10,000 hours, this exposure accumulates. Radiation can damage your DNA, increasing the risk of cancer and other serious health issues. It's one of the greatest challenges facing future missions to Mars or beyond. Scientists are working on ways to shield astronauts, but it's a significant hurdle. Over 10,000 hours, the cumulative radiation dose could be substantial, raising concerns about long-term health effects, including potential damage to your brain, leading to cognitive issues or even neurodegenerative diseases. But not all changes in space are negative. Let's look at your brain. Interestingly, time in space can increase the plasticity of your brain, its ability to adapt to new experiences. In a way, your brain becomes more flexible, more capable of learning and adapting. In space, your brain has to relearn how to process a new set of sensory inputs, how to move, how to orient yourself, how to judge distances. This adaptability could have long-term benefits, potentially helping you to learn new skills more quickly or adapt to new environments more easily. However, the brain isn't just dealing with physical changes. What about the psychological effects of spending so much time in space? Isolation, confinement, and the monotony of the same surroundings can take a toll on your mental health. Many astronauts report feelings of loneliness, anxiety, and depression after long missions. The psychological effects could be just as challenging as the physical ones. Spending 10,000 hours in space means dealing with the constant stress of being away from loved ones, confined to a small space, and facing the vast unknown of the cosmos. It's a mental marathon as much as it is a physical one. And then there's sleep. In space, you don't have the natural cues of day and night to help regulate your sleep patterns. Many astronauts struggle with insomnia or disrupted sleep, affecting their mood, cognitive function, and overall well-being. Over the course of 10,000 hours, chronic sleep deprivation could lead to more serious issues, including impaired decision-making, decreased alertness, and even long-term health problems like cardiovascular disease or metabolic disorders. So, what strategies do astronauts use to cope with these challenges? Staying busy is key. Astronauts follow a strict schedule of work, exercise, and leisure activities to keep their minds and bodies active. They also stay connected with loved ones through video calls and emails, which helps combat feelings of isolation. Maintaining a sense of normalcy and routine is crucial in an environment where nothing feels normal. There's also the knowledge that they're part of something bigger, that their work is contributing to our understanding of the universe and paving the way for future exploration. This sense of purpose can be a powerful motivator, helping astronauts stay focused and resilient. Knowing that they're helping humanity take its next steps into the cosmos can provide a sense of fulfillment that helps counterbalance the challenges of long-term space travel. So let's take a step back and consider the bigger picture. Spending 10,000 hours in space would change your body and mind in profound ways. From your muscles and bones to your heart and brain, every part of you would adapt to the unique conditions of space. Some of these changes might be temporary, while others could be permanent. But one thing is clear: our bodies are not naturally designed for space. We've evolved over millions of years to thrive in the conditions here on Earth. Space travel pushes our bodies to their limits, revealing just how adaptable and fragile we really are. As we look ahead to the future of space exploration, understanding and mitigating the effects of long-term space travel will be essential. Whether we're planning missions to Mars, building lunar bases, or even dreaming of interstellar travel, we need to know how our bodies will cope with the challenges of space. The research being done today is laying the groundwork for tomorrow's explorers, but the story doesn't end there. The real challenge might come when you return to Earth. After spending so much time in microgravity, the return to Earth's gravity isn't easy. Your muscles are weak, your bones are brittle, and your heart struggles to adjust. You might feel dizzy, disoriented, and even have trouble standing. Your body needs time to readjust, to relearn how to function under the pull of gravity. It's a reminder that while we can adapt to space, Earth will always be our true home. So, if you've ever dreamed of becoming an astronaut, remember, space will change you in ways you can't even imagine. But with the right preparation and support, those changes can be managed. The future of space exploration is bright, and who knows what we'll discover as we push the boundaries of what it means to be human. And as we prepare for longer missions, perhaps to Mars or beyond, understanding these changes will be critical. We'll need to develop new technologies, new strategies, and new ways of thinking about human health in space. It's a daunting challenge, but it's also an incredible opportunity. We're on the brink of a new era in space exploration, one where humanity isn't just visiting space, we're learning to live there. Thanks for watching. And if you enjoyed this journey into the effects of long-term space travel, don't forget to like, subscribe, and share this video with others who are curious about the mysteries of the cosmos.